Welcome to the presentation of our paper. My name is Florian. Together with my colleagues Marcus, Fabiola and Daniel, I worked on the paper Enterprise-Driven Open Source Software, a case study on security automation. We are research-wise affiliated with TUM, LMU, BTH and Fortis, and some of the authors are affiliated to Siemens, so also practical experience is covered here. The context of our paper is that Agile and DevOps are both widely adopted in industry now. And since security is an important aspect of software development in industry, it's only a logical step to integrate security into Agile processes or DevOps. This is especially true for critical systems where it's important to comply to certain security standards. However, the contradiction of well-defined waterfall-like processes to ensure security standard compliance and iterative software development raises many challenges. Since automation has proven to be a valuable technique, for example in DevOps, one way of tackling these challenges is to automate security where possible and where necessary. Therefore, the goal of our paper is to understand the current status of security automation in practice, and then to also see what we can infer from the status for industrial practices. Before we dive in, a bit more context. Since it's hard to get hands-on data directly from enterprises, and only using data from one enterprise like Siemens would yield generalization issues, we decided to take a different approach. We focused on enterprise-driven open source software, so software that is mainly driven or contributed to by enterprise employees. This approach allowed us to get a large number of projects in an industrial context. Therefore, our outcomes should be of relevance for industrial practices. For this paper, we defined 5 security activities we want to investigate. These are namely third-party vulnerability scanning, static and dynamic application security testing, secure configuration hardening, compliance and hardening checks, and secrets management. So, now that you have all the context you need, let's switch over to our contributions. Our paper contains 3 contributions. First, we analyzed the prevalence of security activities in CI of enterprise-driven open source software. We then determined types of security tools that are used by these projects to investigate possible causes for their usage, like cost or integration effort. And lastly, we characterized projects in order to compare projects that perform security activities to those that don't. So let's come to our implementation. We use an existing data set for enterprise-driven open source software that was presented at MSR 2020. In addition, we compiled a list of 84 security tools. For each project in the dataset, we crawled the repositories to detect whether CI is performed. Here we focused on GitHub Actions and Travis CI. After removing duplicates, we found around 8,500 out of 16,700 projects performing CI. For each project that performed CI, we then crawled the CI files and, if possible, the CI log files. Using the security tool list we defined in the beginning, we then automatically detected security tool usage via pattern matching in the CI files and the CI logs. After the automatic detection, we performed a manual assessment of 400 randomly chosen projects in order to validate the automatic detection. In addition to that, we surveyed 67 project maintainers. Amongst others, we asked them whether they perform security activities, which tools they use, and how important they rate security for their projects. Based on the automatic detection, the manual assessment, and the maintainer's responses, we then perform the contributions. So let's come to the results. Contribution 1 was about analyzing the prevalence of automated security activities. The main finding was that while project maintainers rated security as rather important, only 6.83% of the analyzed projects actually performed security activities in CI. The main activities performed are third-party vulnerability scanning and static or dynamic application security testing. This indicates both. For one, that project maintainers are aware of the threat that comes with using third-party code, and it also indicates that maintainers have at least some understanding of secure coding and the tooling to test for vulnerable code. However, we have to look at these results in the context of the before-mentioned 6.83%, meaning the large number of maintainers seem to not care or don't know better. In the survey, maintainers also stated reasons for not performing automated security activities in their projects. The three main reasons were: first, that the maintainers see the responsibility for integrating security at the user side. Second, that the attack surface is perceived as too limited, for example, for a CLI tool that is run locally on a laptop. And third, that security activities are performed manually, so for example, before release. In contribution 2, we determined types of security tools used. We found that tools with a low integration effort, like CodeQL or DependerBot, were used the most. We also discovered that most of the tools support multiple programming languages or frameworks. In addition to that, nearly all tools support at least one of the most popular languages, where we take popular languages from the 2020 Stack Overflow Developer Survey. We also found that the popularity of a tool seems to play no role. So there are tools with a lot of stars on GitHub that are used in a few projects, and also vice versa. An extensive list of all tools and how often they have been used can be found in our paper. In contribution 3, we characterized projects to compare those that perform security to those that don't. For that purpose, we used different metrics, like popularity, for how long it has been maintained, and programming languages used. Neither the popularity of a project nor the time spent for how long it has been maintained seem to be strongly related to performing automated security activities. However, we found that certain programming languages seem to have a relation to types of security activities performed in a project. For example, projects that perform third-party vulnerability scanning most often use JavaScript, Python, TypeScript, and PHP. And that makes sense, since all these languages heavily depend on third-party code integration. When we look at static and dynamic application security testing, we find Python, Java, C++, and TypeScript to be the main programming languages. One explanation for that is that these languages are widely used, and thus there are also tools available to test them. So, what are the key takeaways? Automated security coverage is rather sparse, with only 6.83% of the analyzed projects performing automated security activities. The most performed security activities are third-party vulnerability scanning and static or dynamic application security testing. We saw that there are many reasons why maintainers don't perform automated security activities. The most mentioned one is that it's up to the user to ensure security. And last but not least, the types of security activities performed in a project seem to be related to the programming languages used. If you want to have a deeper look, you can find detailed explanations and further findings in the paper. The preprint is available on arXiv. And if you want to go even one step deeper, we uploaded all our material, so the code, the results, and the anonymized survey responses. Go check them out. We would be happy to receive your feedback.
Hello, everyone. Good evening or good morning for the audience. And I am here with Florian Angermeyer, and I hope you enjoyed his presentation of his work on enterprise-driven open source software case study on security automation. For those that have missed my previous presentation, I am Antonia Bertolino, and I am chairing this session and waiting for your question that you can put in the chat. You should be now practical of the tool we have. So you can put your question in the chat, and I will read the question to Florian.
So also from my side, hello Fox. Thanks for showing interest to our paper. It was really a journey, and I would also like to thank my co-authors for doing this with me. This was really awesome. So just feel free to kick your answers in here, your questions, and I will hopefully answer them or be able to answer them. Let's see.
So maybe one question that probably, I don't know, anyone that hear your presentation could have this kind of surprise somehow, because the data that you show are a bit on the low side. I mean, it seems that we all are concerned about security, but then you didn't find a lot of practice in security. How can you comment on this, on the number that you got?
Yeah, well, so I mean, we had these like 7,000 or 8,000 projects that we analyzed, and 8,500, and out of these there were like only 6.83% actually performing security activities, so automated, of course. I mean, there's manual security activities performed, so that might be higher, but we didn't ask for that. I mean, our goal is automation, and even there, what we could see is that only like 1% of these projects actually performed more than one security activity in their project. So that shows that there is really only few security coverage in projects. And then when it comes to even showing, looking at multiple security problems, like, I don't know, static application security testing, and then maybe also secrets management, that's mostly not covered. So this is a big issue, I think.
We have one question from Pei Wang. If there is any indicator about the effectiveness of the automation, the security automation that you studied. Do you have any data?
We don't have any data about that. So we didn't look at what the maintainers do with the findings afterward. We just looked at whether they perform the activity. So of course, that's an important topic. That's something that one of the co-authors is currently focusing his PhD on, but that's nothing we investigated in our paper. But that's definitely something we will do in future. Yeah.
Good point, Pei. So
yeah, that's really an important point, because it's often you have like tools. Also in industry, you have these tools, and you throw tools at your process, but in the end you don't fix the issues, because there's either there's too many of them, so you're just overwhelmed, or there's just like not the process to integrate these findings. So you often have like a separate backlog for that, or you don't even have a place to put your security issues, or the findings. So that's really a big problem. Yeah. But that's more based on my experience from industry, and also the experience I got from the other authors. Yeah.
One question, Pei, thank you. Thanks you for your answer. And then Paul asks if the paper describe the specific automated activities. I would like to encourage this in project that is company use, but I am not sure what to recommend.
Yes, so we structured it into 5 different security activities. These were like third-party vulnerability scanning and so on. I mean, I said that before in the presentation, so I won't repeat them here, but there were like 5. And we then looked at which tools were used for each of these activities, and then also why these tools are used. So for example, for static application security testing, one tool that was used a lot was CodeQL, which might be a thing that you can use in your company, but this is the easiest way to use that is if you're developing on GitHub. If you're not developing on GitHub, then you might need to use a different tool, because the CodeQL might not be available for the other platform, or the integration effort might be just too high. So there might be something different, like Bandit or so, for Python projects that's easier to integrate than CodeQL. So in general, we found that tools that are easy to integrate are used more often, like CodeQL or Dependabot. Yeah. So we have a list that you can look up in the paper. It's definitely far from complete. So there's hundreds of tools out there, but this is like first overview about tools that are used in industry, or at least in open source projects driven by industry practitioners. And also, what we found is that there's from the security activities that are performed, the thing that practitioners looked at the most was third-party vulnerability scanning. So they cared more about the vulnerabilities that were introduced from outside than the vulnerabilities they might bring in themselves, like vulnerabilities in their code, or even like leaked secrets or something. So secrets management was something that was really kind of abandoned. So nobody took care, or only few projects took care of secrets management. So this also shows, I mean, the maintainers are aware that there is security threats, but they fail to perform simple steps like just secrets management, where you just insert or integrate a secrets checker. So they fail to do that. So that's like really just 0.4% of our projects we had performed it. So yeah, might also be a good starting point for you in your company if you're using open source software, for example, to start with third-party vulnerability and then slightly increasing it to other activities.
Thank you. It helps to know what others have put in place successfully.
You're welcome. You can also, if you have questions or want to chat afterwards, just ping me or ping one of the others, like Marcus, for example, and then just we will find a way to help you there.
One question, you have 1 minute and a half. So yep. How did you, from Chang Duk Go, how did you filter the enterprise-driven OSS from the repositories?
So that's a good question. In the beginning, we used the data set that was presented last year at MSR. And that was specifically tailored to enterprise-driven open source software. So software that is mainly driven or contributed to by enterprise employees. So we directly based on top of that. And this was also maybe a side note on that, why we use that. It's always a problem. If you want to get hands-on security data, then you have the problem that either if you just use open source, then you have this generalization problem. And if you use only data from one enterprise like Siemens, then you also have a generalization problem. And getting hands-on from multiple enterprises is really, really difficult to get a feasible amount of data. So using this data set was our trade-off to fix that.
Okay. Florian, we have 20 seconds left. I prefer not to continue the discussion, not to truncate the talking in the middle. So I just greet you. Thank you. You can now go to the discussion room and you could continue informal discussion with the audience if you like. Thank you very much.
Thank you.